Okay, let's get started. Yeah, so thanks a lot for joining again. For those that just joined, welcome. And today we'll be giving a quick 1 hour workshop on how to use AI computer vision to supercharge your productivity. There will be some mentions of Gen AI as well. I'm sure a lot of you may be interested. Yeah, so let's get started. Yeah, so just a quick introduction about myself. My name is Chi Hao, and yeah, I have more than 10 years experience building various computer vision and AI applications. Of course, AI is a rather new topic, especially Gen AI. So 10 years ago, there is nothing like that. So we just have machine learning, right? So machine learning is a building block or the foundation to AI, or what we call as neural network or deep learning right now. And yeah, so we have now in Tapway, at least we have quite a couple of products and solutions, and we have been serving more than 5 countries and more than 300 customers to date over the 10 years. Feel free to connect with me anytime if you would like to, connect with me on LinkedIn to find out more. And as we post quite a lot about AI and computer vision at large. Maybe just a quick introduction about our company. Later, we'll deep dive into the agenda, right? So Tapway is a company formed in 2014, and we have worked with a lot of businesses from across the board. We started off doing a lot of retail, a lot of shopping malls, even until today. And then we venture into manufacturing. We have agriculture. We work with transportation industry, logistics, warehouse, so on and so forth. And to date, we have more than 7,000 video sensors and cameras deployed across multiple locations and across all industries. And in Tapway, our core competence is all about AI vision or vision AI, right? So combining computer vision with neural network or deep learning. That's basically what we do best. Just a quick introduction about our product. So today, I won't be doing too much sales about our product. I really want to educate the public here about how you can leverage, AI computer vision to kickstart your journey when it comes to, automating operation, improving security, so on and so forth in your company, right? So yeah, just quick introduction about our products. We started off many years ago with something that is pretty simple. It's person detection, really, right? So people track, it's all about tracking people movements. So it could be people counting, it could be crowd measurement, it could be demographics measurement, so on and so forth. And then we moved on to tackle vehicles. So the most common objects that you will see on security cameras are these two things, right? A person or a vehicle. So vehicle track is a product that we developed in 2019, and we are now we are capturing more than 2 million vehicles every day right now across highway operators, commercial buildings, as well as residential buildings, and even industrial, for example, logistics, warehouses, and places like that. And Samurai is a new platform that we have launched last year. And this product or platform is really meant for everyday users, right? So if you would like to train a model today to detect something that is totally unique and you can't find the off-the-shelf model or camera to do that, this is where Samurai is really useful. It is a no-code platform to help you to tackle the entire computer vision process that we will be explaining today, right? So yeah, that's basically what we do in a nutshell. So yeah, just before we get started, we will be doing quite a couple of like quizzes and stuff like that. And if you like to stand a chance to win a 2-month free access to our Samurai platform, kindly turn on your video. We'd love to see you. So this will not be just a one-way street. And participate in every single quiz, right? So we will reach out to you for the 2-month free access to our Samurai platform right after this. So yeah, let's maybe what I can do, just as an introduction, I would like to know for the audience today, whether you guys have had any knowledge so far in computer vision or AI. Yeah. How can we do this? Maybe you can give a reaction on the screen here, right? So if you have already some basic knowledge in AI and computer vision, maybe you can give a thumbs up here. All right. Yeah, and I think we can keep it pretty free flow as well, right? So someone has raised a hand. So most of you have some basics. So this is supposed to be a super beginner introduction. So if let's say it's too generic, too general or too basic for you guys, really sorry about that. It's meant to educate really audience with zero knowledge as well. So we are keeping it as simple as possible. Yeah, I'm still not seeing too many people that turn on your video. Yeah, so feel free to do that. One more question before we move along, right? And how many of you are currently a student? Maybe you can give a love reaction, or you can raise your hand as well. How many of you are students? All right, great. So plenty of you are students here. Great. And any of you are working right now already for a company and have a particular usage or use case for your company operation, quality control, security, safety, things like that? All right, so we'll carry on. Let's get started. So the agenda today, right, we will be talking about introduction to computer vision. And then we will be sharing, basically in this introduction is meaning, although we say it's introduction, it's actually quite in-depth overview of the entire process, how you can go from having just images to deploying your first application. Then we will talk about some of the applications that we have done. That means some industrial use cases that we have done. And we talk about some future trends. And perhaps if we have time, we can end with some Q&A. Feel free to just raise your hand at any given time if you have any question whatsoever. All right, cool. So let's get started. First of all, yeah, I would like to ask everyone here about the difference between machine learning, artificial intelligence, and computer vision, for example, right? So can maybe any of you give an explanation of what artificial intelligence is? Any taker? We want to be a bit more, I guess. Yeah, if you want to just voice out, you can just voice out immediately, and just unmute yourself.
Hi, my name is Leonard, and
Hi, Leonard.
okay, regarding on the artificial intelligence, I believe that you will be explaining on the machine learning and related to the classifications of the artificial intelligence. Taking an example, if a camera, in order to recognize a product, we will need to train him and to allow to have uh, the vision system in order to recognize the product through classifications and learning.
Okay. Yeah, I mean, artificial intelligence actually cuts across vision as well as text as well, right? So, like for example, NLP, right? So, it's not just vision, but you are giving a good example when it comes to vision. So, in general, the definition of artificial intelligence is just the ability of the machine to imitate intelligent human behavior. So it's very general. So artificial intelligence is like a big umbrella. That's why we have this kind of a diagram here, right? As a whole, AI is sometimes can be abused a little bit because you can call anything AI when you are imitating intelligent human behavior. But yeah, there are a lot more to when it comes to what is Gen AI, for example, right? So next one is machine learning. So machine learning is actually an application of AI that allows a system to automatically learn and improve from historical data. It can be a bit of mouthful, but machine learning is basically, let's say, if you have a couple of data points, and the standard way for people to learn from these data points is to draw a line, right? So we call that like a linear regression. If you don't know, just look up linear regression. So that's like the simplest way of machine learning. Some wouldn't even call that a machine learning, but it is, right? So basically, this algorithm can learn from a few data points to predict what will happen next, right? So that is machine learning. Now, the next one that has been emerging, I think for the past, I would say 5 to 7 years, it's not new anymore, right? Deep learning. Anyone can explain what deep learning is? What is the difference between deep learning and machine learning? People always get confused about it.
Hi, I'm Chen Heng.
Hi, Chen
Maybe
Heng.
I can take a go at it.
Yeah.
So, from my understanding, machine learning is learning on labeled data sets. So they have been labeled by humans as right or wrong, or cat or no cat. But deep learning is using data sets that have not been labeled, so that they can draw inferences on that humans cannot really find.
Okay, thanks a lot for your answer, Cheng Heng. Actually, both deep learning and machine learning are using labeled data sets. Of course, deep learning, there are two branches of deep learning, which I don't think we'll go into today. We call it supervised and unsupervised learning, right? So you are right that deep learning can also learn from unlabeled data sets. Yeah, so that is what we call as unsupervised learning. But in general, deep learning can also learn from labeled data sets, which is most of the learning currently, right? Most of the models that you see in the market are supervised learning, right? So to be more direct, deep learning, it's another subset of a machine learning, right? But deep learning focuses on using something called neural network. If you are not sure what neural network is mimicking how we as humans think and how our brain works. Our brain has a lot of neurons, and we learn by having neurons that are working as a neural network, right? So artificial neural network is deep learning, basically. Yeah, so a machine learning as a whole can be very generic. You can write an algorithm. You can literally write a couple of lines that does not use neural network. That will not be deep learning, right? So deep learning has been emerging for the past, I would say, 4 to 6 years now. And really, I mean, it has been quite a long time ago, but emerging as in it has been popularized for the past 4 to 6 years. And that's basically what we have done in our company as well for the past 4 to 6 years to look into how to use deep learning to improve, let's say, certain object detection accuracy in the real world, right? So that's deep learning. And these days, everyone has been hearing about generative AI, right? So you must be wondering what exactly is generative AI and what is so different. What is generative AI as part of this deep learning, right? I'll just give you guys an answer. So as we have a long way to go, many slides to go, I just want to cut down a little bit when it comes to, explaining or getting you guys to answer what it is. But generative AI is basically a much more intelligent deep learning model that is capable of generating text, images, and other media using what we call as generative models. If you want to go into the technical details, there are different ways or different techniques that are used right now by most of the big Gen AI companies in order to train a model that is much more intelligent than previously using general neural network or the older neural network. So I won't go into the details right now. So we will just keep it as layman as possible. So generative AI is a new branch of deep learning that is very, very smart and that can now learn from a huge amount of data in an unsupervised manner, and to do much better than the older generation of the neural network. Yeah. So that's basically a quick introduction of different types of words that you have been hearing, right? So you won't get confused next time when people say that, hey, I have a linear regression model and it's deep learning. So you can call kind of BS on that person. Yeah, so you know, there's a lot of sometimes words that being thrown around about using AI to solve problems, but it's inherently not AI under the hood. So it's important for you guys to know that. So yeah, now we maybe can go into computer vision, right? So computer vision also has two branches or two types, right? Which is the general machine learning, the traditional way, versus deep learning, right? So I'm gonna give two examples here. These are typical use cases for computer vision. First one is, of course, I think you have seen that is really for security, is for surveillance, right? So if you like to do certain detection of a person walking across the street, if you want to detect jaywalkers, for example, by pairing with information coming from traffic light, you can basically use computer vision to solve. Another branch of typical computer vision use case, or in the industrial world, we call it machine vision. That is normally for, let's say, object detection, product recognition, or defect detection. So I'm sure some of you may have seen cases like that already, right? So just to explain a bit about computer and machine vision, actually they are interchangeable, right? It's just that machine vision has been used by the industrial world for a long time to describe really limited use cases when it comes to quality inspection in the industrial world, in a factory. Yeah, otherwise you can use that interchangeably. There is no difference between computer vision and machine vision. But there is a big difference when it comes to what is traditional vision and what is deep learning, right? So traditional computer vision has been around, or we call it image processing. So you can use certain techniques to process the image and then to achieve a few results, right? So a traditional computer vision has been around for a very, very long time, even in the 80s and the 90s, right? So I wouldn't say it's new anymore, but with the advancement of deep learning, now we can do a lot more than what was previously impossible to do. So just to show you kind of a diagram here, on the left-hand side, I'm just going to turn on my laser pointer. All right, so yeah, on the left-hand side here, a typical use case for the, especially for factory, is dimension measurement. So I'm sure you guys know what dimension measurement means. And to tell you in a very layman manner, it's pretty simple. An image is made up of many, many pixels, right? So let's say it's 1,000 pixel by 1,000 pixel, or by 700 pixel, which is a 1080p that you guys always hear for TV, right? So over here, if you want to measure the size of this object over here, you just need to count number of pixels and equate it to a certain ratio. Let's say 1 pixel equals to 1 mm. So 10 pixel will be 10 mm. That's exactly what it is. It's very rule-based, right? It's all about rules, writing rules for it. And the second traditional use case is barcode reading, because barcode is very standardized. So it's very, very straightforward to recognize barcode by writing rules, right? That have no variance, no complexity, right? The next very popular use case is a presence-absence use case. And typically, how you do that is using something, what we call as template matching. So for example, yeah, it's closely related to the one at the bottom here, right? So if you would like to know whether the circle shape is present in a certain location, you can write a rule that on the top left, you'll be seeing one circle. So if the circle doesn't exist, then it's absent. If it's there, it's present, right? So it's very, very much rule-based. And it's also popular in the factory floor where everything can be controlled. I mean, environment, right? So shape detection, of course, it's very simple. You want to know how many of this rectangle is there on the conveyor belt, for example. If the rectangle having the right size, if it's not the right size, it is a defect, for example, right? So these are the typical things you can do really with the traditional vision, very much rule-based. Then I'm gonna talk about some of the things that are evolving, right? So in the past, you can do feature extraction or feature detection using traditional vision as well, just image processing. So for example, using a technique called edge detection, you'll be able to know what are the edges of the part that you would like to, or the feature that you would like to have. And you can then extract the entire image to figure out that, hey, this is a template that we would like to see on our production line. So you can do that with traditional vision as long as everything is controlled. So the environment must be 100% controlled. That means you must have the same lighting, the same position, and you must not have any variation, right? So when you have variation is where problem will start to happen, right? So it now in the I would say in the today's world, I would say that this is most of this kind of feature detection is done using deep learning, because you can have a lot more variations. You can be a lot more forgiving and flexible, right? So it can be done on both sides, right? But it depends on the use case. I'll share a bit more about benefits later on for you guys. So part counting, again, it's coming from shape detection. You can count easily if the shape, everything is predefined, well-defined. It has the same lighting uniformity in the environment, right? Same with OCR. If you are trying to detect, let's say, flat standardized text, you can use traditional way to do it, right? But most of the new OCR use case is all done using deep learning these days, just because that there are a lot more variations when it comes to real world environment. For example, a bottle that you see, a round bottle, you will see the text in a curved way, right? So you will not be able to see, let's say, K as exactly the same K that you see here. That is always challenging, right? Even license plate recognition has been existing for a very long time, but the accuracy was always not there until the recent years, right? And that's because you can solve with deep learning. So yeah, on the deep learning side, on the right hand, you can see that we focus on the word complex, because deep learning really helps to solve complex use cases and really open up the scope and open up the environment that you can run computer vision in. In the past, that's why many years ago, machine vision exists, and it can tackle specific control environment. And now with deep learning, you can literally do it in any environment, right? Whether it's rain or shine, dark or shiny, daytime or nighttime, it doesn't matter, right? So you can do very complex object detection use cases. You can do very complex segmentation use case, and you can do classification use case and very challenging OCR, for example, right? So this is just to give you explanation of what is traditional image processing versus deep learning, right? I'll go more into it if you have more questions. So you may be wondering, why do we need computer vision? If let's say you are hiring 3 staff right now in your quality department, and you are already doing it pretty well, so why switch to computer vision? Why invest, right? There are a couple of benefits that it can bring. Of course, number one, humans have human error. This is inherent. You get distracted and you get tired, and then you make mistakes, right? So it will help to reduce defects, because computer vision does not have the same problem as a human do. and then output, right? So maybe a human can do it within 5 seconds, but the computer vision system can do it within 1 second. So now you can increase your output. And thirdly, of course, reduction in workforce, right? In I would say in most of the realistic use cases that we have done before, we are not automating 100%. You still need human supervision when there is a computer vision system or there's an AI system, but it can help to reduce to a very large degree, right? And comparing traditional computer vision that I've mentioned, I think number one, really, if you want to define rules, and if there are too many rules to write, you'll be stuck in rule writing forever, right? So by training an AI model, it's a lot faster. All you need is to fit images to it. And second, you'll be able to achieve very high accuracy with minimal data sets, right? So that is one of the key ways that AI-based computer vision can achieve. And finally, is that it is easy to scale, right? So it is really easy to scale because you can now deploy it to 10 sites. They may have variations in their environment. All you have to do is to feed more images, and it will train and learn from this new environment. Yeah, so that's the difference between traditional and computer vision. So probably I'm gonna just pause here and do a quiz. Yeah, Sarah, would you like to take over and introduce a new poll? So we have launched a new poll right now that you can participate. So this is the question. It's what is the main difference between the AI-based and the traditional computer vision?
Okay, so the poll is already in your screen, in the Google Meet screen, so you can just vote on the right-hand side.
All right, so maybe I'll give another 15 seconds before we move on. Okay, so yeah, I mean, if you are not sure what the answer is, I'm gonna just reveal the answer right now. So that will be D, all of the above, right? So I think I've already covered this, but if you have questions, do feel free to put in the chat box or just raise your hand. All right, I'm gonna move on to describe about different types of computer vision model. So yeah, let's get started here, right? So you can see here we have 3 very different types of detection, right? First, we are detecting directly based on the entire image. Second, we are detecting based on a certain what we call as a bounding box, right? So it's a box that is bounded around the object. And finally, we have the final type, which we are detecting based on the exact edges of the object, right? So these are the 3 types. The first one, we call that classification. It's as simple as classifying the entire image. We don't care where is the object, we just classify the entire image. The second one is what we call as a detection, so or object detection, right? So this is when you detect the object by a bounding box. And finally, we have segmentation. So segmentation is basically detecting the object based on the exact shape of the object, right? So you may be wondering, why do we need 3 types, right? So it really depends on the use case. I'll give a couple of different use cases later to give you an intuition what to use. But in general, segmentation requires a lot more labeling. So it's a bit more human effort intensive. Although with Gen AI, you can do auto labeling quite easily. So that helps with the segmentation. But segmentation has another slight drawback, which is performance or computational resource that's required, right? Because it's a lot harder to detect the shape rather than a bounding box. So the bounding box is typically object detection, is the easiest to do if you don't need to detect the shape. So if you just want to detect the object as a whole, you don't want to know the exact shape, then you should go always with the object detection. But for some reason you like to know the exact shape of the object, then you should go with segmentation. Otherwise, if you have very clear images as a whole that show the object that you would like to classify, you can just go with classification directly. Although these days classification is a bit less used, just because yeah, if you have a very complex images with many objects, it is difficult to classify by just using a simple whole image classification. So yeah, I think I've described quickly. So this is another quiz. So Sarah, you can launch the poll. Yeah, which is the out of all these images, which one showcases object detection?
Yep, poll is live now. You can vote.
I do apologize if it's a bit too basic, but yeah, I mean, I'm trying to just cater for all types of audience today, and we will have a more deep dive course that we will discuss later at the end of today's workshop. So yeah, I think I will just pause here, and you guys can clearly see it will be B for object detection. So it's pretty straightforward. So now I would like to describe a bit more about the entire computer vision process. We call it summary process because that's what our product is called, and also sounds nicer this way. Anyway, so a typical computer vision AI training process consists of 4 parts. Number 1 is what we call as data. Second, data is literally just images, right? Second is labels. Third is train, which is training the model. Finally, once you train the model, you need to deploy it, right? The deployment is also known as inference. So if you have seen the word inference, it's about deploying it in production and then doing prediction on your image. So this is a cycle. The reason why this is a cycle is also very important for everyone to know here, that AI is not trained in one time or one iteration, right? You may need V1, V2, V3, V4, and the accuracy will continue to grow. So this is very different from a traditional approach of writing rules, because all you have to do is just write enough rules and it will work, right? It doesn't work with AI, because with neural network, you need to feed more images to tackle certain accuracy issues, right? So the data module is pretty straightforward. The data module is all about uploading images, right? And I think today we'll just share a little bit of how and what kind of images you should upload and what you should avoid, right? In terms of managing the data sets, it is another topic that we will not go into today. Second is labeling. These days, fortunately, we have Gen AI. So Gen AI can help to do labeling as well, right? I will also explain a bit later about why we can't use Gen AI model in production. Why do we still need to train a model if Gen AI can already detect an object, right? And many people will be asking that. I'll be sharing a bit more later if we have time. And once you have done the labeling, then you will need to review the data sets, right? So yeah, the data review is basically just to check whether the labeling is done right. So once that is done, you can start to train the model. And training a model is not like just you know, train a model and that's it, right? And it will be accurate, right? Magic will happen. A lot of people have the fallacy that magic will happen when you just click a button, right? It's not like that. So you need to constantly evaluate the model. You need to review the data sets. You need to test your model before you decide whether it's ready for production or not. All right, so yeah, finally is deploy. So deploy is, we will talk about how you can deploy it to the cloud and how you can deploy it to the edge. What does edge means? Edge literally just means close to you, right? Edge means that if you have a camera in the office right now and you like to run your AI inference engine or the AI prediction engine close to your office, that's deploying an edge server or edge AI device close to your office. So that's basically the process. Pretty straightforward, but there's a lot to it, right? That's a lot of, I would say, nuances and knowledge that you need to learn about it. So how our training process works is pretty straightforward. I'll use the bottle as an example, right? So you can see there are a lot of bottles here of different sizes or different types or different defects. All you have to do first is to plan what kind of classes or what types of a bottle that you would like to classify or detect, and then you collect images. You feed to a labeling tool into our platform, for example, for labeling, and then you do the labeling. Once you have done the labeling, you can train a model. Once you have trained a model, then you can check for problems, right? So maybe the accuracy problem is that the good bottle is very good, a very high accuracy. The scratch bottle is pretty high accuracy, but the wrong color, it's not good, right? So then you know that you need more data sets to fit into the engine. So that's basically for solving the problem and to have another iteration. And then you train the second version and then figure out if you need more iterations or not until you achieve high accuracy. This process typically can take months last time, right? When we first started, maybe 3-4 years ago, when it comes to having a training pipeline, you may need to take a couple of months for one iteration. But with now a no-code platform, with a simplified automated pipeline, with auto labeling, you can literally train a model within days, right? So it lowers the time required for you to deploy a production-ready model. So yeah, let's have a bit of intuition, right, about how to choose the best images for your AI model. It's a very long topic, so I probably will not go too much into the details. Since we probably have about 20 odd minutes left, I will probably just give you the top 5 considerations. I have another slide on examples. I'll probably skip that or just show you a little bit of what to avoid and what you should consider. First is variability. So very, very straightforward, right? So let's say if you like to detect apple, if you only take pictures of apples on a brown table, now once the model is trained, you put the apple on a white table, and the model may not do very well. The reason is very simple. You are teaching the model to learn from one type of environment, but you never consider various types of environment, right? So background is actually quite important. It is important that you have variability, right? You should take a picture on the brown table, on the white table, on the floor, in the outdoor, when it's a bit darker, when it's a bit brighter, things like that. So variability is very important. Second is consistency, right? So the lighting, the perspective, everything should be consistent, right? So if you are taking, let's say, from one angle, you can take from multiple angles, but it should be always pretty much the same, right? And of course, lighting is important. If you have such bad lighting that you can't see, then it is a problem, because in general, the rule of thumb is if your eyes and you yourself can determine the object through the image, then the model has a chance to learn. But if you yourself cannot be sure what you are looking at, then the image should be discarded. Third is clarity, right? So very simple. The image must be clear. It must not be too blurred. it must not have too much noise, right? The noise and the blurriness, we can teach you again how to generate it, but in general, your picture should be as good as possible. And then through certain techniques, you can add blurriness and noise to each of your good picture. Yeah. And fourth is about background, right? So you can see this image here has a lot of cluttered background, and that could be an issue when it comes to classification. So if you're doing pure classification model, then background must remain as uncluttered as possible. If you're doing object detection, you can of course draw the bounding box around the object, but make sure that of course the foreground, we talk about foreground and background, right? The foreground is clearly distinguished from the background. If let's say you are taking a picture where the foreground and background cannot be differentiated, it could be hard for the model to learn as well. Yeah, so that's the fourth point. And finally, of course, resolution, right? So it's a common problem for many AI models, just because you deploy maybe the wrong camera, or you deploy the wrong zoom for the camera. That means the image that you capture is not very clear, or it's probably as a whole is very clear, but the object is only 1% of the entire image. Then when you cropped out that particular object, it does not have the required pixels. So having enough pixels is very important. So for example, I think the most common use case is number plate recognition, right? So I can show you some of these examples of vehicle plates, right? These are all Malaysian plates. And if you are a proud Malaysian like me, you know that we can do all kinds of plates in Malaysia. We have a standard, but we don't quite follow it. So you can walk into a shop today and you can get one made in the font of your preference, in the distance between character of your preference, in any way or form. So that's the beauty of it. So you can see some of the example here, right? I think if you want to add variability and you feel like you yourself can see this W here, you can let the model learn broken plate as well. This will add robustness to your license plate recognition or OCR model to be able to know a broken W and probably a broken P. But if the brokenness is so serious that it looks like a totally different character, then you should not consider it. Yeah, because that will get you confused. For example, if the P has this curve on the top and the curve dropped off, it is just I, right? So you're not gonna label that and say this is a P. That will be bad for the model. You can see the second example here is pretty blur, right? Do you know if it's V or Y? I myself, I do not know. So if you have confusion like this, it's best to exclude images like this, because if you do this and you label more images like this, the model will get confused between V and Y, right? The third one is also a good example, right? Is that 3.0 or 3Q? Yeah, so that is a major problem for this 0 here, right? Or Q here. Actually, it is a Q. Believe it or not, it is a Q. And in Malaysia, Q also has many different types as well. Some with a longer leg, I would say, or a longer tail or shorter tail. Sometimes the tail is so short you can't see. So in this case, you can't see. So again, you have to be careful, because if you have confusing data, the model will be confused as well, right? So I think clarity is important. If you see this example about VKW177, it's not just that it's not that clear, but also it looks like it's jumbled together. But in general, if you think your eyes can see, probably the model can see it as well. So this is, to me, borderline acceptable, right? So yeah, it depends on your use case. And then you can see the next example again with this extreme Q and also S, right? So the S looks like a 5. You can just, if you don't know what is the convention, if you have no idea about license plate standard, because you are also a neural network, so your brain learns from seeing many plates, you know the standard already, right? So you know that it will not start with 0.5. No plate in the world in Malaysia starts with 0.5. But can the model learn? Model does not have context on what is the format of license plate, right? So things like this you should try to avoid. So yeah, quiz time again. So we need Sarah to help me launch the new poll, which is already launched right now, right? So yeah, the question is pretty straightforward. What are the essential factors contributing to high quality images, right? What should you consider in order to have a high quality computer vision model? I'll just pause for 10 seconds. All right, so yeah, I'm sure you guys have answered, and it's like a give me questions, right? So the answer is D, which is all of the above. And a slightly more tricky question. So this one is about which images you should exclude from your data set. So you have 6 images here. Obviously, you like to detect the object, but what would you exclude as out of these 6 images? The poll has been launched, so you can answer them. All right, so yeah, this maybe need a bit more time, but I'll end here for the quiz. So this basically has 3 examples that should be avoided. Number 1 is brightness. So on the number 3, sorry, I shouldn't say number 1. So I'll just call the number ID number, right? For the image, it will be 3 here. So 3, you can see it's a little dark, right? Number 1, number 2 has clear feature of the object that you like to detect. The 4th one has a very clear as well. And the 5th one is too blurred, right? Maybe it's possible. I would say it's a 50-50 case if you ask me. But if you have another type of fruit or a nut that is very similar to this, this is just not enough features. Yeah, so I would recommend to exclude this. And number 6, it's again contrast issue, right? This is what we call a contrast issue. It's just not very clear, right? So we would typically exclude 3, 5, and 6. So yeah, I will maybe just speed up as we have actually quite a lot of examples to show. Gen AI can help with auto labeling. And that is one of the innovations that have come out over the past 2 years, right? In the past, you have to label one by one. Let's say if you want to identify the cat, you have to do that. But now with a button and you just click the prompt, you'll be able to label all the cats on the picture, which is great, right? This will help with helping to cut down the time on labeling. The second one is called auto segmentation, right? So you can see here, the cursor moved to the object, and the Gen AI can detect very smartly what exactly is the object. Yeah, you can even zoom in and label just the snail at the top if you want to, or you want the frog with the snail. So it is intelligent enough to detect the entire edges of the object smartly. I'll just touch a little bit since we are a bit crunched for time. Again, this is an introduction. The full course is actually a 2-day course for you to learn end-to-end about the whole process. What are the classes? The classes can be types of object, defects, or texture, and a lot more, right? So it really depends on your use case, right? So it's very important for you to learn how to select your classes. So what exactly is class? In this example previously that we have, yeah, like cats, cat is a class, right? Frog is a class, snail is a class. So these are classes, right? And for you to start labeling, you need to plan properly what are the classes for you to label, right? So if you see this example here, right, how many classes we can assign? I'll probably, normally I like to do Q&A, but because we are crunched for time, we probably won't be able to do that. So I'll just give you the answer directly, right? It depends on the use case. If you just want to label or detect how many apples are there on the table, you can just label the apples. If your goal is to detect what type of apple is on the table, then you need to go deeper, right? So you can have a single class model if your goal is just to detect apples. If your goal is to detect different types of apple or different variants of apple, then you need to have, let's say in this example, one type called Fuji, the other type called Honeycrisp, and the third one called Golden Delicious, and yeah, and so on and so forth, right? So you have different types of apple that you can classify. I'm not an apple expert, so I wouldn't be able to comment on this. But yeah, it depends on your use case and what you want to achieve in the end. Just to tell you a little bit about the training process, very quickly, we typically have 3 types of training set, right? We will use this example of a person trying to study for a final exam and to pass your exam. I'm sure everyone has gone through that cycle before, right? The reason why we split our data set into 3 different subsets is so that first, you have the train set, which is your textbook. So if you want to learn about a subject, you will need to have a textbook that you can learn from. You should have a dev set, and the dev set is like practice exams or mock exams, right? So you have maybe some, if you study for exam before, you'll go through some questionnaire. So you will be able to test yourself, hey, is my understanding correct, right? So this is a very important, data set for you to figure out whether you are ready or not for the final exam. And of course, once you train the model, that means you are ready to sit for exam. So the test set is the final measurement of accuracy or how well your model performs. That is test set. And once you pass the test set and you get the required accuracy, you graduate, right? So you pass the exam. So that's how I would say the training process typically works. So I would say that's the data split process. The training process is pretty straightforward. So once you have labeled all your data sets, we will typically take a snapshot of your data, right? So a snapshot is like just collecting all the data, the images and the labels together in one single format that can be understood by the training pipeline. Then you need to provision the training compute resources. These days you guys have seen NVIDIA stock price increasing. That's because of this, right? Because you need GPU to train a good model. You can probably use a CPU to do inference, but GPU is required for training a model. So it's very important that you have either a AI server in your office, or in these days and age, we typically use cloud to do it because it's a lot faster and you can just pay per use. You don't need to buy an expensive server and put it in your office. And then finally, you can start the model training. So for model training, yeah, I think I would not talk so much about it, but this is a typical graph that you can see, right? We call that losses, which is just error, right? So the higher it is, that means the less accurate it is. So we have something called epochs. Epochs means iterations. It's a number of times. So let's say if you read the same chapter twice, you will have better understanding of the subject, right? So if you study the chapter 3 times, maybe you can have even more understanding of the subject. So it's basically what it means, right? So it's to learn from as many example again and again to have more confidence, right? So you would like to see the loss going into 0. That means the error rate is very, very low and the accuracy is high. Finally, I think I will leave you with this thing, which is how you can deploy, right? So there are 2 ways, again, how to deploy. First one, you can buy an AI edge server, similar like how you train a model, but you don't need so much power to run what we call inference, right? So inference means prediction. And you can get this device close to your environment, your end production site, and you can link to cameras, and then you can then set up the whole training, the inference pipeline, which we can deep dive into this in the longer course. And then you have the cloud deployment, which typically works by capturing images, right? So you can take an image and we give you the prediction. So if you guys have tried tools like Google Lens, it works very well when it comes to doing cloud AI prediction, right? So depending on your use case, if you want real-time video stream, we will recommend to do edge deployment. Otherwise, cloud deployment would be the best. I will just quickly run through some of the examples that we have done, and then we can maybe just run a bit over time if you guys don't mind, to cut into your lunch time. We'll have probably a few minutes for Q&A. Yeah. So this is CAN classification and counting. Yeah, so you can see we train the model on CAN classification. This is for oil and gas, right? So you can detect the conditions of the cylinder, right? So these are all done in real time in real production environment. This is for palm oil bunch counting. Again, palm oil is a very localized industry in Malaysia, so you can see exactly how it works when it comes to detecting the bunches. This is a durian grading example. So we have one of the world's first Musang King durian grading system using 7 cameras. So this is a lot harder to explain how we built this. But yeah, when we have the time, we will do that next time, right? This is for moving vehicles. You can install AI system with cameras inside a moving vehicle to detect things like lane line, lane features, curb, road signs, so on and so forth, right? And this is a typical what we call a key point model. I did not mention this type. This is one of the other computer vision type, which is what we call key point. It's very famously used for facial recognition and posture detection, basically. And this a unique and fun way to also do quality check on pizza. Yeah, so these are some of the examples, right? I'm just gonna skip through them. I will also skip through future trends since we don't have much time right now. But basically, yeah, with Gen AI, there's a lot more things you can do without training a model. But of course, the problem is always latency. If you have tried GPT before, it takes a while, right? If you want to run computer vision, sometimes you need to run 30 frames per second. You cannot afford to lose time to do prediction. That is why Gen AI is never used for real-time video streams. So yeah, I will just skip all this. So yeah, just a final slide here, right? The reason why we are throwing this introduction to give you a preview, if you're interested to embark on a journey with us to learn how to deploy computer vision end to end, right, with AI. We have a HRD Corp, HRDC claimable course right now, right? So yeah, this is a 2-day course. You will learn the ins and outs of how to start from zero, basically having just images or even having no image. You have a problem statement you can bring to the course and say, hey, I would like to detect defect on my production part, and I don't know where to start. Through these 2 days, by the end of 2 days, you will have already a prototype model trained already. It is really to accelerate your team's development and to be able to get to a production model by the end of 2 days. So it's very practical. There will be hands-on lab. There will be direct usage of our platform itself to learn how to label and train model and deploy it. Yep. So do scan the QR here, right? And you can get 500 ringgit off if you use the code today. So yep, I'll just hang on to this slide for a bit longer, and I would like to perhaps open the floor for some Q&A. sorry for just running the time a little bit over the supposed 12:30. Does anybody have any questions so far? All right. Maybe I'll give another 1 minute. You can think of something to ask. Is AI fun? Absolutely, absolutely. And I think it's the best time to be doing AI right now. It's not just fun; it's practical. It helps to automate your life and your work in many aspects. Today we just touch on how it can help replace your vision, what you do with vision, right? There's also using it to improve robotics, to improve, speech, right? So that's a different aspect of AI right now that can be applied to the real world. So Sharu Asman, you asked about which industry actively apply this AI currently. I would say all industries. Yeah, really. So we started off doing retail and shopping malls. That is 2016, really. And of course, at that time, we use a traditional rule-based algorithm. We detect an object that looks like a head, and then we start counting that object as a person. Then we started running into problem. If a person holding a balloon, we detect that balloon as a head. So that is the limitation of writing rules, right? So that's when we started developing, AI model or neural network model. And now we have applied this across to agriculture, like you see, manufacturing line. You can do that for F&B, for food defect. You can apply this for worker safety. You can apply that for reading gauges in the industry. So it's really across the board. Wherever you use human eyes to detect something and you would like to automate that, you can apply it. All right, sorry, Labib Rahman asked about what's your opinion on some people being scared of how AI could influence the world. Oh, this is always the philosophical question. It's to me, it's about automating manual, boring work, right? So let's say if you are a person working on quality inspection and your job is to flip 1,000 parts a day. I think that is the job that we would like to automate with AI, right? We do not want to take away highly intelligent job. Although it could be the future as AI gets smarter, that it will start to, get into the industry where highly intelligent workers are excelling right now. But in the immediate future right now, it's about helping people to get more meaningful work rather than doing boring, repetitive work. Hope that answers your question. Does AI need to integrate with machine learning as well? Yeah, I think, again, the understanding is, like I mentioned on the slide before, machine learning is a branch of AI and deep learning is a branch of machine learning, right? It is similar, but it's different. So again, it depends what your use case is. Most of the time these days, when people talk about AI, it's deep learning, meaning it's neural network related. Yeah. What's the best way to start learning AI? Well, today is a good starting point for you. So hopefully you will already learn a little bit about the process of AI. And if you would like to apply that in your workplace or in your universities, or if you're pursuing a career in AI, yeah, there are tons of resources online that you can find, or there are tons of HRDC certified courses as well that you can sign up for, including ours here. So yeah, hope that answers your question. Last one is, if Gen AI in computer vision will generate detection images, how about Gen AI in recommendation system? What would it generate? I suppose you're talking about recommendation for, let's say, yeah, it's a bit general, your question, but let's say it's talk about product recommendation. Of course, if you can feed enough data of how people shop, let's say on your website, let's say if you're Shopee, you want to learn about if you want to improve your recommendation engine, you can use Gen AI to improve the accuracy, right? One thing that Gen AI have, it's what we call a transformer network. So you can learn about the keyword called transformer. GPT, the T is transformer. Transformer is different from the O, I wouldn't say O because it's still relevant. The CNN model. You can also look up CNN. It's convolutional neural network. It's a bit technical, but yes, if you use transformer network, you can definitely improve accuracy of your recommendation engine. Okay, how can I integrate AI in cybersecurity as I want to be in the field of cybersecurity? I am not a cybersecurity expert, although we built our platform with a lot of consideration of cybersecurity. Again, it's the same as my answer for the recommendation engine, right? You can actually use transformer network to train a much better model these days. Yeah, so all you need is data, of course, a very well labeled data. In your case, it's probably a lot of text data, right? A lot of logs, maybe from security breaches and things like that. Then you can fit those into the same network, right? Today we talk about vision, which is images, but essentially for any other use case, you can fit text, you can fit speech data, any types of data to the same transformer network, yeah, in order to train your model. All right, so Gan Esa asked about what's your opinion of the NVIDIA CEO statement, no need to learn coding, anybody can be a programmer with technology. Yes, I absolutely agree. And that's a reason why we built this no-code platform over the past 2 years, because we have a strong belief to democratize AI. AI should be democratic, right? It should be easy. Everyone should be able to train AI and deploy AI in your own work environment or in your own personal environment. So the reason why we have this introduction workshop as well as the 2-day training course is so that by the end of the second day, you don't need to learn coding, because if you want to learn coding, it may take you a lot longer. In 2 days' time, you can start to use AI already. Yeah, so that is democratizing AI. So I absolutely agree with NVIDIA CEO statement. All right, so if there's no more questions, I guess we can end the workshop today. Thanks a lot for staying with us. I hope this session is useful, and we need your feedback. So if you can just scan the QR here, you can give us feedback on how we should improve the session, what sort of other materials or topics that you would like to cover. We would like to hear from you as much as possible so that we can run a much better workshop, or we can split the workshop into maybe 2 sessions in the future for everyone here. So thank you so much for your time today. And I hope you have learned a lot and digest a lot, and hope to see you soon. Thank you.